Hello, I'm Quillen, and today we are going to be continuing our discussion of the analytical ways to manipulate and find limits. So, in the past couple of videos, we talked about the basic rules of limits, and now we're going to start applying those to actually find some rules and some patterns. So, if you ever find a difficult limit to solve, you can at least know where to start. Say you have this function x squared minus 3x minus 4 all over the quantity x minus 4, and you want to find the limit of that function as x approaches 4. Well, the first thing you might try and do is plug in 4 for x, and let's see what happens when we do that. So that would give us 4 squared is 16 minus 3 times x is 12 minus 4, that's 0, divided by 4 minus 4 is also 0. Um, so 0 over 0, as you know, is undefined, but specifically because it's 0 in both the numerator and the denominator, this is what's called an indeterminate form. There are several indeterminate forms. This one will show up a lot. I apologize again for the traffic. This is the same night that I recorded the last video. 0 over 0 by itself will not tell you anything. This means that just from this, we know nothing about this limit. So then, how can we solve it? Well, if you think back to your Algebra 1 class, or maybe your Algebra 2, depending on the order that your school system arranged it, you can factor quadratics and then simplify fractions. This smells like partial fraction decomposition, but it's not that. So let's pull this down here and factor the numerator. And the way that I learned this is just to eyeball it. So I'm going to just be eyeballing it, but I'm going to be walking you through my logic as I do that. And you won't always be able to do this because the factors of the numerator will not always be the same as the terms of the denominator, but it's a good place to start. And I'm looking at this and I'm thinking, and I basically make a t-chart in my head. So I'm going to write out the t-chart that I'm seeing. So I need something that is going to, two things that are going to multiply to give me -4, and that are going to add to give me -3. And so I am thinking, well, because it's negative, they need to be opposite signs, and the one with the larger absolute value, so the one further away from 0, has to be negative. And so the first one I would try would be 1 and -4, because I always tried the one with 1 first. And then I find out that, automatically that works. 1 minus 4 is -3. So that means that x squared minus 3x minus 4 equals x plus 1, the quantity times the quantity x minus 4. And I'm saying the math aloud a little bit weird because I think it'll help you get used to it, but you do not have to know how to say it. And I'm sure that I am going to make several mistakes in dictating the math. The important thing about this is that x minus 4 appears both here and here so that they cancel, and the resulting fraction, and therefore the resulting limit, looks like this. Because remember, there are some implied brackets right there, and as long as we're working completely within inside the brackets and following our rules of algebra, we can do whatever we need. So this has now become the limit as x goes to 4 of x plus 1. And this we can just plug in and we will get that this equals 5. There's your final answer. Now, let's check by graphing the function. So we're just going to go over here and type in our original function, x squared minus 3x minus 4 all over x minus 4. And you will see that just eyeballing it, as x gets to 4, it seems like y would be getting to 5 if it were defined. Of course, it isn't defined, but it looks like 5. That means that our original answer, 5, is correct. In this video, we are also going to talk about one more way of finding limits that otherwise we might not be able to, and that is with rationalization. So that was with factoring. Now we're going to talk about rationalization. I will link to the Khan Academy page for this lesson if you would like some more practice, because this lesson will most likely require you to practice more than these last couple ones have. So say you have some function, or say you want to find the limit as, actually, hold on, let me pause really quickly. So sorry about that, something I needed to take care of. So we want the limit as x approaches -1 of this radical rational function, x plus 1 over the square root of x minus 2, or sorry, x plus 2 minus 1. So the first step that you would take is you would just solve for x, see if that tells you anything. Well, the top is going to be 0 because -1 plus 1 is 0. And then this bottom would be -1 plus 2, so the square root of 1, which is 1 minus 1, so that's 0 over 0. That's our indeterminate form. That means we don't know anything just based on this. So we have to find a way to manipulate this so that it won't give us 0 over 0. So what I want you to do is think back to your algebra classes yet again. Think about a concept called the difference of squares. That stated, I'm going to write this over here in red, that a squared minus b squared equals a minus b times a plus b. And one way that you can sort of extrapolate that is that this can also mean a minus b squared, you may see where I'm going with this now, equals the square root of a minus b times the square root of a plus b. And that's just something that you learned, hopefully, in your algebra class. If you didn't learn it, memorize it now, and then play around with it after the video to see if you can build an intuition of why that's the case. So let's see how we can apply this to our current situation of having 0 on the bottom of this fraction? Well, I think it's pretty clear that the square root of x plus 2 is going to be our a, or it's going to be our square root of a, and 1 is going to be our b. So we have, I'm going to use yellow for this now. We have this part of the expression already. And we want this other part that I have not circled. So the way that we would get that is we would have to multiply, of course, but whatever we do to the denominator, we must also do to the numerator to keep the fraction equivalent. So let's see what that would mean. So I'm going to work in red. So we have x plus 1 over the square root of x plus 2 minus 1. And then we are multiplying that by essentially the conjugate of the square root of x plus 2 minus 1, which is the square root of x plus 2 plus 1. So go ahead and do that. And what you will get on the bottom is, of course, x plus 2 minus 1, because 1 squared is 1, and this the square root of x plus 2 all squared is x plus 2. Square and the square root cancel each other. And then on the top, all right, so when we multiply these together, the bottom is going to become x plus 2 minus 1, because 1 squared is 1. And then let's leave the top separated, because that's a good habit to build. And a lot of times it's easier to FOIL later than it is to FOIL earlier and then have to re-expand things. And then we know that we're going to be left with x plus 2 minus 1. If we combine like terms, we will notice that this becomes x plus 1. And then notice that this x plus 1 and the x plus 1 on the top cancel with each other, leaving us with just the square root of x plus 2. So now let's find this limit. So what we want is the limit as x approaches negative 1 of this function, the square root of x plus 2. And let's just try plugging in negative 1. Well, negative 1 plus 2 is 1, and the square root of 1 is 1. And again, by going to Desmos or any other graphing calculator, I like Desmos, we can check our answer. So right here is, okay, so this is a very good moment, because even I took calculus, I was very good at it, and I've moved on beyond calculus, I'm now teaching it to you. I still make mistakes in my algebra. And my silly little mistake was that I forgot to also transpose this plus 1. So our answer is 1 plus 1, which is, of course, 2. And now if we look at our graph, if we go to negative 1 right here and then trace up, it looks like our graph would be at 2 if it were defined, but it's not. Let me try and locate that so you can be sure. All right. So I hope this video has been helpful. Like I said, I will try to link some extra practice in the description. If there's not extra practice linked there, then that means that tomorrow's video will be some extra practice with this. I hope that you will continue with me on this journey through calculus, and I hope that you have found this video helpful. Thank you. This is Quillen, signing off.